Hi everybody, my name is Ann McClung and I'm a mentor with the Pit Pirate Robotics Team 2642 and I work at the Center for STEM Education at East Carolina University. Arr, go Pirates! Today we're going to learn how to build a pasta car with various pastas that you might find around the home. Do you have spaghetti? Do you have lasagna? Better yet, rigatoni or ziti. Or these are fun, the little bow tie pastas. Or these are also unique. I call them wagon wheel pasta, but they're round shaped and they're great to use for wheels. So today we're actually going to build a car to explore Newton's laws of motion, understanding the forces that act on cars as well as the motion that it will travel, how far it will go and how fast it will go. So now let's take a look at how I built this car. Okay, so now we have our car built. Hope that was easy. Other pointers I want to share with you is when you're building the car, make sure that I'm using ziti pasta right here. Make sure that it was lined up parallel to each other, but also making sure that it's forming a right angle so that the axles here are aligned correctly. We want to make sure our car is great alignment, okay? Also, now we're going to test it. We're going to look at various items dealing with Newton's laws of gravity as well as the force of motion. So in order to do that, we're going to need a ramp. You can find any kind of surface around here. I have a basic poster board here that we're going to use for a ramp. And you can adjust the height and you can change it to see how it affects how far the car will travel. You can also time it as well. So on this lesson, we're going to basically put the car at about this, or put the ramp at this height, and we're going to load the car on the ramp. Now, the other thing, what I would like to do is make sure that my axles are kind of in the middle. My wheels are kind of in the middle, and then I'm going to release. And I'm gonna go 1, 2, 3, go. And you can see how far the car actually travels and you can measure it. Maybe you have a meter stick around or a tape measure, somehow measure, or measure by the squares, but be unique on how you do that. Now, we can also see how fast it travels. If we can measure out so many squares, how far it travels in a certain amount of squares, we can also calculate how fast it's going. That's speed. Speed is distance divided by time. So these are all unique features that we could test. Another way, as a good scientist, is to change your model as an engineer. Engineering processes, we're always changing how to make it go a longer distance. So maybe try changing the size of the car. Maybe take your lasagna bed and actually split it to maybe it's only half of the distance and create your car. But create it exactly the same, but change a variable in the car and test that as well. So there are a lot of unique. So what we're doing here by lining it up on the board like this, we're using gravity. So gravity is an attraction between two objects. So gravity is actually pushing the car to where it goes down on the ground. So the ground pushes up, the resistance of gravity pushing down creates the car to fall down and travel the distance. okay? Then with the wheels, using that motion, it moves across the floor. But then the car will actually slow down. And that is a force called friction, okay? So friction will slow that car down till eventually it comes to a stop. I hope you've enjoyed this lesson for today in making cars. Now I want you to go one step further. I want you to take your car, change its shape, change its length, change the type of materials that you're using. I want you to really go outside the box and be that engineer. I know you can do it. And again, thank you so much, and I hope you've enjoyed it. And please come back and join us for another edition of our Homemade Science TV lessons. Bye.